Let's take a look at this question here. They gave us a function z is equal to x squared y plus e to the y. And then they claim that if x is changed from 6 to 6.01, so x is changed by just a small little amount, and y is also changed a small amount from 0 to say 0.02, they would like us to approximate the change in z using differentials. After we approximate how much z will change by making these little changes in x and y, then they ask, is this actually a good approximation to how much z actually does change when we change x from 6 to 6.01 and y from 0 to 0.02. So to begin this question, they're asking us to use differentials. So let's go ahead and write down the formula for using differentials for this question. So we would have that the change in z is approximately equal to the partial derivative of z with respect to x times the little change in x plus the partial derivative of z with respect to y times the change in y. And so now what we need to do is we need to figure out what these pieces are actually equal to. So the deltas are actually the easiest. So delta x, so how much does x change? Well, x changes from 6.01, so this is the end of x to the beginning of x. So x started out as 6 and ended as 6.01. So this change in x is 0.01. Similarly, the change in y is equal to what was the final y, 0.02, minus the initial y, which was 0. So the change in y is 0.02. And now we need to calculate these partial derivatives. So the partial derivative of z with respect to x is equal to the derivative of the first term with respect to x is 2xy, and the derivative of the second term of z with respect to x is just 0. So this becomes 2xy. And we want to take this derivative, we want to evaluate this derivative at the original location. So we want to evaluate this at the original x and y. So the original x and y were 6 and 0. So we want to evaluate this at x equals 6 and y equals 0. So when we go ahead and do that, and we plug this in, we get that dz by dx at the point 6, 0 is 0. Because when we plug in 6, we get 2 times 6, but when we plug in y is 0, we get 0, so the derivative is 0 there. So let's now calculate the partial derivative of z with respect to y now. So if we look at the equation for z, we take the derivative of the first term with respect to z, and we get x squared. And if we take the derivative of the second term with respect to z, we get e to the y. And if we evaluate that at the point 6, 0, what we find is when we plug in 6 to x, we get 6 squared. So this is 6 squared plus e to the 0. And if we add those things together, we end up with 37. So the partial derivative of z with respect to y at 6, 0 is 37. And the partial derivative of z with respect to x at 6, 0 is 0. So now we have all the pieces we can plug back into our formula. So this differentials formula says that the change in z is approximately equal to the partial derivative of z with respect to x, which in this case was 0, times the small little change of x, which is 0.01. So 0 times 0.01, plus the partial derivative of z with respect to y, which in this case is 37, times the little change in y, which is 0.02. And when we actually calculate this, 0 times 0.01, of course, is 0. 37 times 0.02 is 0.74. So what this is saying is that if we went from having an x value of 6 and a y value of 0, if we just nudged x and y a little bit and we went to x is 6.01 and y is 0.02, what would happen to z? This is saying that z would approximately change by 0.74 when we make those changes in x and y. So this is the answer to the first part. The second part asks us, is this a good approximation for the actual change in z? So how do we calculate the actual change in z? To calculate the actual change in z, what we're actually interested in is what is z at 6.01 and 0.02 minus where they were originally. So let's calculate that now. So z at the point 6.01, which is our new x point, and 0.02, which is our new y point, is equal to 6.01 squared times y, which is 0.02, minus or plus e to the y, which is 0.02. So this is our new value for z. So z at these new locations for x and y. And if you actually calculate that, it's approximately 1.7426. And now if we actually ask what was the value of z at our original x and y, so 6, 0, we get that z at 6, 0 was 6 squared times 0 plus e to the 0, which is equal to 1. So how much did z actually change when we moved from x equals 6 to 6.01 and z equals, or y equals 0 to 0.02? What was the actual change? The actual change in z was, this is where it ended up, 1.7426, and this is where it started, 1. So the actual change was 0.7426. So this was the actual change. This was our approximate change, 0.74. So yes, this is a good approximation. And we really shouldn't be surprised by this because z, or x and y, did change by a very small amount. The larger you change x and y, the worse and worse this approximation becomes.